In this lesson, we're going to practice solving two-step inequalities. These are just like solving two-step equations, except for the symbol now is an inequality symbol. And there are a few things that happen occasionally with solving two-step inequalities that we're going to have to watch for as we do this. So we'll do some basic examples of this. The idea is to get x all by itself over here. And we really want to work toward the x, but we need to get rid of this 5 that everything is divided by first. So when you want to get rid of something that's being divided by, you multiply both sides by that term. So since it's divided by 5, I'm going to multiply both sides by 5, which makes the 5 over here cancel. 5 divided by 5 is 1. And so I have x minus 3 on the left side, the inequality symbol in between them, and then 4 times 5 is 20. And so now I've eliminated the fraction, really. This was a divide by 5 fraction. And now I can solve the inequality by adding 3 to both sides. And so then x is less than or equal to 23. When I put those two together, this makes a 0. So all I have left on the left side is x. And so there's my solution is x is less than or equal to 23. The whole idea of solving an inequality is to get x alone. And so you want to start getting things away from the x. In this case, adding 1 to both sides will eliminate the 1, and I'm left with 4x is greater than or equal to 3 plus 1, which is 4. And so now I have 4x is greater than or equal to 4. And so to get the 4 away from the x, I divide both sides by 4. And then I get x is greater than or equal to 4 divided by 4, which is 1. And so that's the idea with these. Just like solving equations, the only difference now is a symbol in between is what's called an inequality symbol. And this is all in preparation for graphing these solutions once we get to that. So right now we're just practicing the idea of being able to take an inequality and saying, okay, what is the inequality relationship with x alone? So I get a minus 5 on both sides because that additive inverse of 5 makes the 5 go away. 5, positive 5 and negative 5 makes 0. So I have 4x is greater than 21 minus 5, which is 16. And so 4x is greater than 16, divide both sides by 4, and I get x is greater than 4. And you can always go back and check on these. So if I picked a value for x that was greater than 4, like 5 is greater than 4, and I put it back in here. 4 times 5 is 20, plus 5 is 25, which makes this true. It's greater than 21. So we can see that values of x that are greater than 4 make this inequality actually work. So let's do a few more examples of this. A couple simple ones and then a more complex one. So again, I'm trying to get the x alone, which means I want to get this negative 9 away from it. So if I add 9 to both sides, and 2x, so the 9 goes away, is greater than 9 and 7, put together makes 16. So I'm just combining those, positive 9 and positive 7. Dividing both sides by 2, so x is greater than 16 divided by 2, which is 8. So again, a fairly simple example. I'm going to jump over to number 6 on the introduction page here. And not a whole lot of difference here. We have x divided by 5 plus 2 is greater than 6, so I'm going to minus 2 from both sides to make this 2 go away. Positive 2, negative 2 makes 0. So x over 5 or divided by 5, is greater than 6 minus 2, which is 4. So now I have x divided by 5. I want to get rid of that 5, so x is by itself. I'm going to multiply both sides by 5. That makes the 5 go away. 5 divided by 5 is 1. 5/5 is 1 whole, so the x now is alone, and it means it's greater than 4 times 5, which is 20. So sometimes dealing with the fractions can be a bit of a challenge. One more example here on number 10. We have again a fraction. X minus 4 divided by 2 is less than or equal to 6. I want that 2 to go away. The only way to make it go away is to multiply both sides by 2, because then 2 divided by 2 is 1. So now I have one of these, x minus 4, is less than or equal to 6 times 2, which is 12. So the 2 went away by multiplying both sides by 2. And now I have a fairly simple inequality if I add 4 to both sides. X is less than or equal to 16, because the 4's go away. I'm left with the x. This x just comes down, and the inequality symbol stays there. And that should be enough examples of solving two-step inequalities. The process is the same. You're always trying to get x by itself by either multiplying, dividing, adding, or subtracting terms away from the x until the x is all by itself on one side. And then you have numbers on the other side with the inequality symbol in between.